In this video, we're going to be discussing how to create master, bias, dark, and flat frames, as well as how to apply them to your data images. So we've already got AstroImageJ open here, and there's two ways to access the utility that we want. The first is this CCD data processor, this DP button. You can press that. You can also go up here. Let's see, I believe it's in, you have to have an image open, right? So if we open an image right here, we're going to open one of our science images. And then here, if we go to Process, we can click on Data Reduction Facility, and it pulls up these two windows. The coordinate converter, which we'll not discuss right now, we'll discuss that later, so you can safely close that window. But the CCD data processor is what we want. So again, we open this through the menu associated with this image that we have open. So if I happen to close that, we can go back to our toolbar and click on DP, and again, it opens up the same windows. As we said just a second ago, the coordinate converter can be ignored because the panel we want is this data processor. Okay, there are a bunch of checkboxes and inputs here that if you don't get just right, it will cause problems. So this is probably the most important video you could watch as far as data processing, and I recommend that you pause it multiple times, that you make sure you're following along, because every little bit has got to be set up. It's a bit like a cake. If even your baking powder's off by a little bit, cake's not going to work. So same story here. Okay, let's talk about the main parts of the data processor. So on top we have the science image processing. So what this top part is, it's going to tell us to apply this to our science images. So our pictures of the stars and galaxies we care to work with. So you notice it's got these several things checked by default. We'll talk about those in a minute. Okay, we've already explained in the other video what a bias, a dark, and a flat are. So here it tells us whether we want to build or enable these several calibration frames. Okay, and again, you can choose build or enable. There's other things, so we'll go through all of these. So the first thing we're going to do is decide how we're going to use this data processor. So what you can do is you can use this to create a single bias, a master bias that is. You can use it to create a master dark and a master flat. You can do those all at once. You can do them step by step. You can do everything all together. So what we're going to do is we're going to try to have this all run at once, and that way we only have to use this window one time. Okay, so here we go. First of all, we want to check that our path names and our file name patterns are set. So the directory, that's these ones here. Okay, those are all our directories. We've got to make sure those are set properly. And the way that our files are named, that's got to be set correctly. Over here on the side, these numbers, right now they're set at 0. That tells us, and that's an indicator of whether or not it has found the images that we are wishing to process here. Okay, so first of all, our directory, where are the images found? So if we click on this little folder, we're going to tell it where to find them. So mine happen to be in this thing I called calibration files. So that's where it's going to be. Here you can see that that's what's open right here, and I've got a collection of biases, darks, and flats right there right now. Actually, so I got to be careful here. That's where my calibration files are. That is not where my science images I'm going to work with here. This one right here, that's not where it's found. That's in my downloads folder, so I got to make sure that it's looking there. This top one, this NGC 5746, that's the image, the science image we're going to work with. So we got to make sure it knows how to find that. So click on that. Okay, file name pattern. Well, the easiest thing to do is just click on it. And there we have it. Now what if you have multiples? Well, that's where this wildcard comes in. Okay, so that's this asterisk right here. So now if we look at my downloads folder, you can see right here that I have 3 of those, 1, 2, 3. Now, did it know how to find them? Well, kind of, because the names of them are, they have a pattern, but they kind of start to get different right around here. So you can see that the pattern isn't different enough for it to find more than one. So what I want to do is I want to throw out all of this stuff and just have an asterisk. So an asterisk is a wildcard that tells it that the file names they are common in this sense, but then after that they might be different. So you can see that the number here has changed to how many it has found. It's found 3, which is how many I have here in my downloads folder. So that is as we've expected here. So enable, we want to keep that there. Sort num, I've had poor success with that, so I tend to just uncheck that. Now the other thing that can really, really mess you up, and you don't know why, is this file name number filtering. It's checked by default. I tend to ignore it. Okay, so I just uncheck it. And then you notice that all 3 of them are here. It's found them all. So we've got this set up now. This top bunch of controls are set up to process our science images. Okay, the bias subtraction. So in my case, we have here the biases. I've got 5 of them downloaded, and we want to merge them into a single master bias that will be applied. So as we discussed in the other video, you want to remove the noise by merging several of these together. So what we're going to do is we're going to do a build that's set on median. In astronomy, you definitely want things set on median. Okay, so that with a build check, that means we're going to build it out of these 5. It's going to produce a single master bias, and we're going to call it M bias. You can change this to whatever you want. You can call it master bias or M bias. Either way is fine. Okay, now we need to tell it where to look. So I'm going to click here, and again, we're going to be looking in my documents, this calibration files. Click there. Now you see that it's the file name, the default that it's given us is a little bit wrong. So in my case, it's a capital B bias, and then if I throw out this underscore and stick in the asterisk, it's going to find them all because, again, of our wildcard there. You notice up here we have the .fits.fts. You don't have to have that because the wildcard will find us. We got all 5 found. Now in this directory, I need to tell it where I want to put the final product, the master bias. I'm going to put it in the calibration files folder. So that's down here. This is what I want to name it. You notice it says 0 right here because it hasn't found one there. There's not one there right now. So we need to make it. Now the enable checkbox, that we would check that if I want to apply this to my science images. So in other words, up here where I enabled the processing of my science images, for the bias, dark, and flat, each one of those, you can choose whether or not to apply them. So we probably do want them enabled here. Okay, so we've got the biases set up. Now the darks, we're going to have to build those as well. Median, combine is always what we want. Again, in my case, those are all in the calibration files folder. Our end result, our master dark, we want that kept here. Now you notice it's got a guess at how they're named. It's a little bit off, so I'm going to call it dark. Again, with our wildcard, it found all 5 of my dark images here. The master, you can, again, doesn't matter what you want to call it. I prefer to call it master dark. So here we go. All right, now let's talk about these other buttons that are here. Okay, so the debias, we want that checked. All right, scale, it's important that you check that as well. So scale, what that means is it's going to scale the exposure time of your dark images to that of your science images. So in this case, they happen to match exactly. These darks are 5-minute darks, and my images happen to know they're 5 minutes, but it's better just to scale it. Okay, so just leave that scaled. All right, so that's all set up. Now and again, enable is checked. So now under the flats, we're going to build those. Again, we have to set our directory to where they're found, and they're in my same calibration files folder. We're going to save the master to that same place, calibration files. There we go. All right, flat, so you can see that again, it was a close guess the AstroImageJ gave me, but not quite there. So now it's found them. I have 6 of them. And again, it's important that you match the filter of your flats to that of your science images. So we've typically taken care of that for you. You shouldn't have to worry too much about that because we take care of that on the end when we take our pictures. Okay, in image correction, you can just leave all that alone for now. They're unchecked, that's good. Fits header updates, general, that's good. Leave that checked. Plate solved, we're not going to be using that, so you can just leave that unchecked. Save calibrated images, you want to leave that enable. So what this is going to do is it's going to save your calibrated images separate from your input ones. This is important because if you mess up, you want to go back and start over, try again with your input data. So what it will do is it will create a new subdirectory, in other words, a little folder in downloads. It's called pipeline out, or in my case, it's downloads. It'll be in whatever directory you put here. It'll put a little folder in there called this, and the file names will be changed so that they have an underscore out at the end of them. So here, if I look at my downloads, it's going to have this format, but it's going to put out at the end of them in a subdirectory, so I know that they've been processed. All right, so then let's see, anything else we need to check? I think that's it. So we're going to, again, all these numbers match up. So if we just hit start, it should go like we expect it to because there's 3 images that it's going to process, and this will tick through as it processes them. So here we go. Let's hope this works out. So we get a log here. Log's always important to watch. Okay, so we're watching. It's creating our master bias. Looks like it did just fine. Now the dark. Looks like it's created, and you can see those appearing here in my directory as they're cooked up here. So we get our biases. and it's creating the master flat, which is a little bit longer process. So there it is, right down there. Okay, now it's opening my science images. It's applying these calibration frames we just made, and the whole process worked just fine. We can check it. You can see here whether our work worked or not. So here's the input one. You can see it's just the name up here, but over here, this is our processed image because it says .out. So we know it's processed. Another way we can check, of course, is in the FITS header. So we open the FITS header for the .out version, and you scroll to the bottom, and you can see down at the very bottom, here on lines 122, 23, 24, 25, see it was bias, dark, and flat corrected. Now those lines would be missing on our input here. If we click on that guy, see they're not there. All right, so it was processed. Now it's hard to tell just by looking at it because again, our scaling here is set really poorly. So if we change that, as we discussed in our other videos, you can see that this is actually an image of a really cool galaxy. So if we can zoom in here a little bit, and again, if we can carefully choose how the background is scaled, you can see it better in certain images rather than others, but this is a good place to check and see how the processing went. So for example, if we zoom in here and we look, we can see that we have that dark pixel that's right there, that's removed. This one somehow survived, but you can see these dark places. It's removed those dark pixels that would otherwise be present over here. Okay, so that's how you would process your science images and also how you would build your master calibration frames.